Okay, so here we go. The second part, which is going to be the next 5 questions. So the next 5 questions is an electricity company offers a minimum consumption rate to any user whose electricity consumption is less than 40 kilowatt hours during a particular month. Define A as the event of choosing a random user in a given community and not exceeding, that does not exceed this minimum in January. And B, the same event, he doesn't exceed this minimum in July. A and B refer to the same user. So the probability of A is 0.8, the probability of B is 0.7, and the probability of both, of him having both, is going to be 0.9. So this is an and. Remember, I'm sorry, this is an or of having A or B, because this is a union, it's going to be 0.9. And what we want is the and, the intersect. So how do we get this intersect? Here we go. Let's put the probability of A, the probability of B, and this right now is going to be the probability of A union B. And that is actually an or. If we want to remember, it's an or. It's A or B, okay? So it's 0.8, 0.7, and 0.9. Now, how do I get this particular, which is going to be the P? Let's put both, okay? If you remember this formula right here, the formula to get this formula is the probability of A plus the probability of B minus the probability of both. Okay, so now we have it. We have A, we have this first part, we have A, we have B, and this is what we want, this both. Okay, so if we want to put it easier, what we can do is play around with the numbers, like algebra. Not like algebra, it is algebra. So if we want to do this, it would be probability of A or B. And this is positive, this probability of A, but we'll bring it over. So it'll be minus the probability of A. And we'll bring the B, which will be the minus the probability of B. Okay, and that will equal the negative value of the probability of having both. Okay, so let's go ahead and do this. So the probability of A or B is 0.9 minus the probability of A minus the probability of B, and that gives me 0.6. And it's negative, this is negative, they cancel out the negative, so the answer, if you could divide it and bring it divided by 1 or -1, and it would give you a 0.6. That is the possibility of it being both. That's the intersect, okay? This is the intersect. So that one right there is that one, okay? The probability of the minimum consumption, the probability of the minimum consumption will not exceed in exactly one of the 2 months, okay? So this is that it won't happen in one of the 2 months. How would you do this? Well, it's fairly simple. Now we have, so we have the intersect, which is going to be 0.6, and with that, now we can see how much of it is going to be a probability of A, just probability of A, taking away the intersect, just 1, because it says exactly in one of the 2 months. So what is it? This one, it would be this, the probability of A minus the intersect. This is the intersect where it's both A and B, but we only want it to be 1. So we can put 0.1 And it would be is specifically this 0.7 minus this 0.6. Did not, sorry. Just this 0.7 minus this 0.6, and to have just one. So it'd be 0.2 plus 0.1. 0.2. I'm sorry, my mouse is not working. It's going to be 0.3. So the possibility of the minimum consumption will not be exceeded in exactly one of these 2 months is going to be 0.3, because it's not asking, it's not an or, and it's not an and, it's basically asking just one of these months would be 0.3. Okay. And I never put the question. And so that was question 6. Okay, there it is. So the possibility of it being both, we got that, was 0.6. The possibility of it being just A or just in January was 0.2. The possibility of just having it in July was 0.1. Okay. So here's the next one. Brooks Insurance Incorporated is about to start offering life insurance targeting 60-year-old men through the internet. The mortality rate indicates that the probability of surviving that first year is 0.98. If the insurance offers the service to 5 possible clients, what is the probability that 5 of the men will survive in that year? So if you remember, these are independent events. If one man dies, it does not mean that the other will die. These are independent events. So this is the multiplicative law. And what is the probability of at least one of them not surviving? Okay, so here we go. So I'm going to put what? Question 7. So it was 0.098 if surviving. Okay, so we can probably say probability of A of surviving. So we have 5 men, so that means it's going to be 1 times 1. It's not plus, sorry, times that, times that. I have 4, 1, 2, 3, 4, one more. It's going to be 0.9039. Okay. And then it says, what is the probability of at least one not surviving? Well, we know how many are surviving. Okay, out of all these possibilities, these are that they will survive. One, at least, the probability that 5 of them will survive. So the probability of B, which is that at least one won't survive, one of these men, is going to be fairly simple. So it's going to be 1 minus this particular, what we got in the probability of A, of all 5 men surviving. 1, we'll take it out. It's going to be exactly the answer, 0.96079. Okay. That is a possibility of at least one not surviving, because we already know what's the possibility of them surviving. Okay. Now we can move on to quit smoking. There's a new chewing gum that helps people quit smoking. If 60% of the people that use this method quit smoking, what is the probability that from a group of smokers, at least one quits smoking? Okay. So we know that 60% of them quit smoking with this bubble gum. What would be the percent? And what they're asking here is, what's the probability that from a group of 4 smokers, at least one quits? So the other 3 might not necessarily do it. So since we're not talking about that the rest of them quit, we're talking about at least one quits, and the rest, well, we don't know if at least the other will not. So the probability that they won't quit, so that we'll put 0 because they won't quit, is going to be, if the probability was that they will quit for 60%, the probability that they won't is going to be 0.4. And it's going to be 4 men, for women, 4 people. It's 4 people, I think. 0.4 times 0.4. So the probability that none will quit smoking is going to be 0.056. Okay. Now let's do the probability that at least one will quit smoking. So we can put that. And when we say at least one, it could be all of them, but at least one won't do it. Okay. Equals to 1. So it's x is greater than or equal to 1. Is going to be, we know what it takes for the none of them to do it. So since this is an or, it'd be 1 minus them not. So at least one of them is going to be 97. That's a good number. That's a good data for this particular chewing gum. And this is question 8. Sorry. Let's go to question 9. There it is. So now we have a gas station. And in this gas station, 40% of the clients use regular gasoline. That's event A. 35% use event use plus, which is event B. And premium will be event C. Okay. Of the clients that use regular gasoline, 30% fill their tanks. And let's start with this because this is going to be a table. So we know A, B, C, if I'm not mistaken, A, B, C, A, B, C. And one is regular, plus, and premium. I'm just going to make the side note because I won't remember. Regular, plus, premium. Okay, there it is. And then we also have another thing. It says, of the clients that use regular gasoline, 30 fill their tanks. Okay, 30 fill their tanks. 30% fill their tanks. Of the clients that use gasoline, 60% fill their tanks and 50%. Okay, so we have, and it's D. Sometimes it's all jumbled up. Of the clients that use regular gasoline, 30% fill their tanks, event D. So event D, we'll put here, and then not fill their tanks, we'll put E, just because it makes sense. So let's go ahead. Regular clients are 40%. Okay, so 40% is 4. Then 35 use gasoline, 0.35 use regular, and that should give us another 25.25. Okay, that's the total. So we know that total. Then we have, of the clients that use regular gasoline, 30 fill their tanks. So 0.30 times 40 is going to get it. That means that 0.70 don't fill their tanks. Okay. Then 30 use regular, 30% fill their tanks when they're plus. 30% fill their tanks. Other than they use regular, and it doesn't say here. 30% fill their tanks. Of the clients that use regular gasoline, 30% fill their tanks. Of the clients that use plus, 60%. And I'm sorry, I'm sick. So plus, it's going to be 60 fill their tanks. And that means 40 don't fill their tanks. And 50% in premium. So 50% fill their tanks, and that means 50% don't fill their tanks. And we can sum it up. Okay, that's one. Perfect. Then the question is, what is the probability of a client asking for plus gasoline and filling the tank? So plus gasoline and filling the tank, that would be this intersect of 0.21. Okay, so let's go ahead and put A, and it'd be this one, just so that later you can check it. Then what is the probability of a client filling their tank? Okay, so B, of filling my tank. So let's go ahead and maybe, let's put the letters so that it's easier for you. So it's the probability of, it's going to be being that, and I'm going to put and filling my tank. Okay. Then it was the probability of filling my tank. So the probability of filling my tank, which is D, is going to be this number because it's a total. It's not asking me another one. Then it says, if the client fills the tank, what is the probability of asking for regular, plus, or premium? Okay. So this is going to be, it's given that. So it says, if the client fills a tank, what's the probability asking for? So fills a tank. So if I ask for regular, given that I'm filling tank, asking for plus, given that I'm asking for a full tank, premium gas, given that I'm asking for a full tank. Okay, so it's going to be P, and it's going to be A, given D, and I didn't number right, a little line, given P, probability of B, given D, and P, C, given D, of full tanks. Okay, so if you remember, it's 0.012 in the total filled tank, 0.21 divided by the fill in the tank, and point divided by fill in the tank. Okay, so this is my answer right here. Okay, those are the probability that I would have in specifically each of these possibilities. 0.2637, 0.4615, and 0.2747 is if I ask for a full tank, what is the probability of asking for regular, asking for premium, or asking for plus? Okay. The next thing, it says, is there an independence between the type of gasoline and the actual action of filling the tank? So the first one, it says, is there an independence between the type of gasoline? So the type of gasoline can be any of these. Okay, so let's go ahead. Probability of A. What is the probability of A? Well, the probability of A, what would be the probability of A? The whole A is this one, right? And then it says, what's the probability of a gas and the action of filling the tank? So the action of filling the tank is going to be, for example, probability of A given D. And we already know that. The probability of A given D is that one. So are they equal? No, they're not equal. And since they're not equal, they're not independent. They're dependent, one on the other. So it is not independent. They're dependent on each other. So it does depend. The percentage or the probability of you filling your tank is going to be dependent on the type of gasoline that you choose. Okay,